Good day everyone! In this video, we will discuss about truth tables. Given a proposition, its truth value shows all its possible truth values. For an instance, if you have one proposition, say P, then its truth value will be either true or false and will be denoted by the following table. So the table shows that for the proposition P, we have two possible truth values which are true or false. Moreover, if you have two propositions, say P and Q, then its truth values will be proposition P and Q are both true, proposition P is true, and proposition Q is false, proposition P is false, and proposition Q is true, or maybe both propositions are false. The simplest logical operator is the negation operator, which is denoted by bar. The negation of a proposition P is denoted by this symbol, read as not P. Therefore, this symbol here is being read as not. If the truth value of our proposition P is true, then the truth value of not P will be false. If the truth value of P is false, then not P will be true. Notice that the truth value of the negation is always the opposite of the truth value of the proposition. The conjunction of propositions P and Q is denoted by P and Q. This symbol here denotes and, which means conjunction. The propositions P and Q are called conjuncts. This table shows the truth values of the conjunction. If P and Q are both true, then P and Q is true. If P is true and Q is false, then P and Q is false. If P is false and Q is true, then P and Q is false. If P is false and Q is false, then P and Q is false. Notice that for the conjunction, the only possibility that it will be true is when the two propositions are both true. The rest, it will be false. The disjunction of propositions P and Q is denoted by P or Q. The propositions P and Q are called disjuncts. The table here shows the table of values for the disjunction of propositions. If P is true and Q is true, then P or Q is also true. If P is true and Q is false, then P or Q is still true. If P is false and Q is true, then P or Q is true. If P is false and Q is false, then P or Q is false. Notice that the only possible way for P or Q to be false is when the two propositions is false. Moreover, as long as one of the propositions is true, then the truth value of P or Q will be true. The conditional of propositions P and Q is denoted by if P then Q. This is the symbol for the conditional propositions. The conditional if P then Q may also be read as P implies Q. The proposition P is called the hypothesis, while the proposition Q is called the conclusion. The table here shows the truth values of the conditional propositions. If P is true and Q is true, then if P then Q is also true. If P is true and Q is false, then if P then Q will be false. If the hypothesis is false and the conclusion is true, then if P then Q will be true. If the hypothesis is false and the conclusion is false, then if P then Q will be true. Notice that there is only one possibility that it will become false, and that is when the hypothesis is true but the conclusion is false. The rest of the possibilities will be true. The biconditional of propositions P and Q is denoted by P if and only if Q, and it will be denoted by this symbol. The proposition may also be written as P if and only if Q. The propositions P and Q are the components of the biconditional. The table here shows the truth values of the biconditional of propositions. If P is true and Q is true, then P if and only if Q will be true. If P is true and Q is false, then P if and only if Q will be false. If P is false and Q is true, then P if and only if Q will be false. And finally, if P is false and Q is false, then P if and only if Q will also be true. Notice that the biconditional propositions P and Q will only be true if the truth value of the propositions will be the same. If they are both true, then it will become true. If they are both false, then they will become true. But if they have different truth values, then the biconditional propositions will be false. Let us use these definitions in finding the truth value of the following compound propositions. Take for example that we have the following propositions P, Q, R, and S, and let's say the truth value of P is true, Q is false, R is true, and S is true. Let us find the truth values of the following. Let us start with the first one. Let us find the truth value of P and not Q. The first thing that we need to do is to determine the truth value of not Q. Notice that from the given, Q has a truth value of false. Therefore, not Q will be true. Since we are after the truth value of P and not Q, then we need the truth values of P and not Q, which are true and true. Since the truth value of P is true and the truth value of not Q is true, then the truth value of P and not Q will also be true. Therefore, the truth value of this compound proposition is true. Let us try another one. Let us find the truth value of the given P and not P. In here, we need to find first the truth value of not P. Since from the given, we have the truth value of P to be true, then it follows that not P is false. To find the truth value of our problem or our given, we need the truth value of P and the truth value of not P. Since P is true and not P is false, then P and not P is false. Remember that for the conjunction, for it to be true, we need to have the truth value of the two propositions should be true. So since we have here true and we have here false, then it will become false. Therefore, the truth value of the compound proposition P and not P is false. Find the truth value of the given not Q or R. The truth value of Q is false and the truth value of R is true. Therefore, Q or R will be true. To find the truth value of the given, we need to negate the truth value of Q or R. Since Q or R is true, then the truth value of not Q or R will be false. Therefore, the truth value of the compound proposition not Q or R will be false. I hope that you have understood the lesson. This is our last discussion for the general mathematics. Thank you so much for listening and see you on our next video.